Hello students, this video is on section 2.8, ordering fractions. When we're trying to put fractions in a certain order or decide which one is smaller or larger, we need to be comparing pieces of the same size. So we're going back to the type of things that we were doing with adding and subtracting fractions that we did not need to do with multiplying and dividing, which is having a common denominator. So if we have fractions that don't have a common denominator, we need to create them by using our equivalent fraction techniques that we've been using throughout this chapter. So an example of a question like this might say something like, compare 1/3 and 3/8. And you would use something like this, which means less than. Or you could use this one, which is greater than. Or, I'm sure you're all familiar with equals. If they are the same size, you could use that. So if we're comparing 1/3 and 3/8, that requires us to be looking at what size the pieces are. Thirds and eighths are not the same size pieces, so we need to make them the same size pieces by using equivalent fractions. 3 and 8 go into 24. So here I have 1/3 and I have 3/8. And that's not 3/8, is it? There. So this becomes 24. And I got that by multiplying by 8. So I'll do the same thing to the top. 1 times 8 is 8. 3/8 is going to give me a 24 as well, but now I'm multiplying by 3. Do the same thing to the top. 3 times 3 is 9. Now it's apparent 8 24ths is less than 9 24ths, and therefore 1/3 is less than 3/8. Okay? So this would be the actual answer that we would want. It's nice to be able to use this, but they're not asking us about 8 24ths and 9 24ths. They're asking us about 1/3 and 3/8. So this would be the answer that you would respond to that question with. You might consider, if we have fractions that are the same denominator, that it's going to be a pretty straightforward piece. If we are talking about 5/9 and 6/9, we already have the same, so we can tell right away. But there won't be many like that. The nice thing about comparing fractions is that because our equivalent fractions aren't used in the final answer, the fractions that they give us are, we don't need to use the least common denominator. We can use any denominator, and therefore we can simply multiply the denominators together. An example of that would be 5/16 and 9/24. I don't know what the least common multiple of those are, but I can multiply them together. And so I'll have to do a little bit of work. 16 times 24. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. 0, 12, 1, 2, 3. So 384 is our denominator. Yes, that's a huge number, but that's not really the number we care about. Okay, so in order to get from 16 to 384, all I had to do was multiply by 24. I just took this one. There's a smaller number that these both go into, but I don't want to do the work for it. And multiplying is pretty quick. So I'm going to multiply 5 times 24 as well. 5 times 24, 20, 10, 12. Okay? If I'm doing this very quickly, pause the video, make sure you're getting the same numbers as I am, because it's more important for you to be able to do it than for me to be able to do it. So make sure you're getting the same thing. Since I am going through this quickly, I expect you to be working it at your own pace as well, since you can pause and restart the video. 24 to 384 went 16 times. So I'll do the same with 9. 16 times 9. $144. It's now apparent 144 is bigger than 120. And so 120 is less than 144. And here is the answer we want. 5/16 is less than 9/24. So we don't need the least common multiple of the denominators because those numbers aren't appearing anywhere in our answer, only these ones are. Okay? I'll do one more example. I'll do a couple more. Another one would be 8/20 and 6/15. Okay, 20 and 15 have a common multiple, but I'm going to do it this way instead. Since 20 is a factor of 10, I cover the 0. 2 times 15 is 30, and then I'm going to put another 0 on it, so 30 and a 0. So these multiplied together is 300. That makes this easy because I know I did this times this. So times 15 and 8 times 15. 8 times 10 is 80 and 8 times 5 is 40. So 8 times 15 is 120. With 15, what I did was I just multiplied by 20. I can do the same with 6. And 6 times 2 is 12. But 6 times 20 is 112 and with a 0. So 120. So what you might be able to see here is that these fractions, when they have the same denominator, have the same numerator as well. So they are considered equivalent fractions. Again, here's our answer. Okay, and I'll do one more for you. 3/5 and 4/9. 3/5 and 4/9. 5 times 9 is 45. Do the same with the top. 3 times 9 is 27. This one is 45 by multiplying by 5. Do the same thing with the top. 4 times 5 is 20. Which one's greater? The denominators are equal now. We're looking at the same size pieces. So there's more of the same size pieces here. Therefore, 3/5 is greater than 4/9 is our solution. Okay? I'll split this section up into a few videos because there are different topics in it. So I'll see you again soon.